Good afternoon, morning, and evening, everyone. Welcome to Data Engineers Launch 80. Our speaker this afternoon is going to be Obi, and he's going to be going over Apache Spark resource managers. The hosts for this event are Rahul Singh and myself, Akli Ohiri. We do need help finding speakers and sponsors for this event, so if you're interested in either opportunity, please reach out to me at the email address listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally surrounded around data. You can find out more about all the various different groups and events at datacommunitydc.org. So what do we cover here? We cover everything from the ingress and egress of data and everything in between. We cover everything from databases, ETL, data wrangling, and all the tools and processes in the data engineering world. At this part of the launch, we'd like to invite first-time comers to this event to introduce yourself, what part of data you work in, what you're interested in learning, and also how you found the Data Engineers launch. I think that'd be a nice introduction for everybody in the chat. So if you're new here, please go ahead and add that to the chat. Group rules, if you have a question, ask it, be light and courteous to others, and of course, share what you know with us. Throughout the presentation, if you do have questions, I like to defer to the host. Before Obi's gets kicked off with the lunch, he'll let you know how he'd like your questions asked, and then we'll just take it from there. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. Thanks to our program sponsors, Data Wrangler, DataStax, Wavical. Also, thanks to our organizational sponsors. And then we have a quick 15-second announcement. So if you have any job, meetups, hackathons, conferences, or classes, please go ahead and leave the links to those below in the chat. And we are hiring here at Anant full-time and part-time positions. To learn more about those positions we have available, please visit curious.anant.us. And we do have various events coming up. We have our weekly data engineering lunch and our weekly Cassandra lunch. Please visit anant.us/events for more information on the events we do have lined up. We have our latest Cassandra runbook updated. Please go download that now. We'll have a link to that in the chat as well. It is free, so get your copy while it's still available. And with that, I'll go ahead and hand it over to our presenter for this afternoon, Obi. Obi, over to you.
All right, thanks. Give me a second to share my screen. All right, so as you heard, my name is Obioma Anomnachi. I'm an engineer here at Anant. Our topic today is Apache Spark resource managers. I apologize if my voice is off or for any coughing or sneezing, as well as the lack of a demo today, which is all caused by me recovering from being sick. So our topic today is Apache Spark resource managers. As the blurb says, we're talking about local versus standalone versus Yarn versus Kubernetes, as well as Mesos, but I didn't put it on there because it's depreciated. This is actually a topic that has caused some confusion for me in a recent client project. I couldn't keep straight whether we were talking about the resource manager, whether we were talking about running in client or cluster mode, or whether we were talking about how many nodes the cluster itself had. And so this is going to go into detail about Spark Resource Manager specifically, but we'll also touch on the distinction between client and cluster mode and how that's different. But first, the general Spark introduction. We do this a lot because we talk about Spark a lot in Data Engineers Lunch. But basically, Apache Spark is an open source analytics engine, basically made for big data. It is made for processing data in cluster, and you can run all sorts of different ways. Usually when we talk about it here, because we do a lot of work with Cassandra, we generally talk about DSE analytics, but in this case, most of this stuff is actually applicable to open source Spark, as well as potentially stuff like Databricks or Amazon EMR, but we'll talk about those briefly in a second. So the topic is Spark resource managers, which obviously begs the question, what is a resource manager? You might also see them called cluster managers. What they do is determine the distribution of resources and work on a given Spark cluster. So that's separate from the resources that are given to master or worker nodes, how many CPUs are available to them, how much memory is available to them. That's a separate concept. What the resource manager does is it determines how those resources are split up within the nodes, and how applications can be granted access to them in order to actually do work, which is also a different setting than deploy mode, which is the client mode, cluster mode split, which deals mostly with the location of the driver. So in client mode, you run the driver node on the machine that is running Spark Submit, and it communicates. So you get your client, it stays the connection to your client stays open. And then in cluster mode, the driver is put on the cluster and you don't have easy access to that client. The resource manager options available in Spark are local, which it might be an error to describe this as a resource manager, but it belongs in this talk anyway. Spark Standalone, Yarn, Mesos, which is depreciated as of Spark 3.2 and is apparently up for removal in some future version, and then Kubernetes. All right, starting off with local. Like I said, maybe not a resource manager, still an interesting portion of this talk. In local mode, you forego the need for a resource manager by running all of the components within a single JVM process. You decide on this when you provide your master IP. If you decide local, you can provide it in the form of local brackets in or local brackets star. And what this does, well, first, this works with any of your Spark binaries. So if you're using Spark Shell, Spark Submit, or PySpark, the way you pass in the master determines which resource manager you're using, kind of. And those binaries can all use local as a setting. Local with no brackets defaults to a single thread for your application. Local N creates N threads for your application, and local star creates as many threads as CPU cores that are available to the JVM process. If you don't provide a master flag at all, Spark defaults to local star. So this is important because this can be true even when you are, say, on one of the nodes in a cluster that is running Spark with one of the other resource managers. So if you submit your job and you don't provide a master flag properly, it's not going to be utilizing the resources on your cluster. It's just going to start a JVM process on that node that will run your application. And basically what happens when you're running in local mode is it starts a driver as well as the executive processes all within this single JVM, and they communicate between each other within it. And you don't get the benefit of being on a cluster, but you get more fine-grained control of how many threads are available. So moving on to the first actual resource manager, Spark Standalone. It comes bundled with open source Spark. So if you download any of the Spark binaries, that's what you're going to get. When you're running Spark Standalone, each node that wants to be part of the cluster has to have a compiled version of Spark on it. Spark Standalone is the simplest architecture that we're going to talk about today, besides local. And it consists of a master process, a single master process, generally, and potentially many worker processes. The master accepts applications that are submitted externally, or say from one of the nodes on the cluster, and it schedules worker resources. So what's going on the workers and how many resources that those processes are allowed to use. And then the worker processes launch executors, which are the things that actually perform tasks. in Spark. So your driver is one of is essentially an executor process, and then the executors themselves that do the actual work of the Spark job and communicate back to the driver, which talks to the master and worker JVMs to determine what it should be doing. So in order to run a cluster in Spark Standalone, you use the scripts that they provide in order to start the processes on the relevant nodes. You can go onto the specific nodes that you want to use and run start master.sh or start worker.sh scripts. The start worker.sh script requires the master IP address, but you can run those scripts on each of the nodes you want masters or workers to be running on. Or you can set up the conf workers file and then use the provided launch scripts, which will go to each machine and start masters or workers as described in that file. So how does resource allocation work if you're using Spark Standalone? Basically, when you create master and worker processes, when you start those processes, you determine how many resources are available to them. So how many CPUs, how much memory. And that becomes the general pool that Spark can draw on when assigning to those lower level driver executors, or if we look at this chart, you decide how much the master JVM has, the worker JVM has when you launch them. And then when they create drivers or executors, they split up that amount and determine how many resources each of those processes get. So this chart here is sort of describing the architecture internally of a Spark Standalone cluster. So your client JVM is external, you run Spark submit, it submits to the existing master JVM, which communicates with the worker JVM. It tells one of the worker JVMs to spawn a driver. While launching executors on any worker JVMs that are going to be involved in the process. And we'll talk a little bit about how that is determined in a second. But the executor JVMs do the actual work by communicating with the driver node. They do individual tasks, and which tasks go to which executor is determined by that driver. If you look at the lower levels of this diagram, inside the driver JVM, there is a scheduler, the Spark contacts live there, and the Spark application lives there, while on the executor JVMs, individual tasks live there. Okay, so in terms of scheduling between applications, if you're running multiple applications at once, Spark Standalone only allows FIFO scheduling, first in, first out. So if two requests for the same resources come from two different applications, whoever requested them first gets those resources. But that's not the default behavior of Spark Standalone. By default, applications want to use all the cores available on the cluster. So they want to use up all of the available resources, which would limit your number of jobs that can be run at one time to one, because all those resources are already in use. If something else requests them, they're in use, they can't be used. So only that first application can be run at a time. So what you would want to do is to limit Spark cores max in the Spark conf. You can do that by passing in a conf value with your Spark submit, or you can do it in the code of your application, setting the setting in the Spark conf. Oh, I never covered questions. So I can't actually see YouTube chat, so Akwi will need to communicate to me if there are any. And generally, I prefer to take questions in between sections, but since there's no demo today, anytime that we're moving on to a new resource manager is probably a good time for questions. So if there are questions about local and questions about Spark Standalone, when we get to the end of this section, then I'll pause for a second and try and answer those. So you set your Spark cores max, which means that each application will only be able to basically reserve the set number of cores in the system. And then you can also configure how many cores get assigned to each executor, which would mean that a single worker node could potentially run multiple executors. By default, you limit yourself to one executor per worker. So that executor uses up all the cores on that individual worker node. But if you set Spark executor cores manually, you can have several executors for a single application run on one worker. You can't have, I believe, multiple, you can't have executors for multiple applications running on a single worker node. And then because Spark Standalone generally uses a single worker node, that's a single point of failure that could be very bad for the stability of your cluster. You can mitigate that by having Zookeeper manage it. Basically, if you're using Zookeeper, you set up Zookeeper and it runs a number of Spark master nodes that it coordinates. And then whenever you're passing in your master IP, you pass all of them in a list. And if one of them goes down, Zookeeper will basically send that request on to the next one. And then local file system based recovery happens per node. Basically, each node keeps track of what's going on and saves that to the file system so that if the master goes down, when you bring it back up, all of those tasks can resume on their individual nodes once there's a master again. So this, obviously, if you want to use this, requires some extra coding, either to detect when the master is down and turn it back on, or all the other various automatic processes that don't happen here. Basically, if your master goes down, you will need to go to each node and start that recovery process as well as start up the master, but it's possible to potentially automate pieces of that process. All right, we're about to move on to Yarn. So if there are any questions now. All right, guess not. Okay, so moving on to Yarn. Yarn, I believe, stands for yet another resource negotiator or something like that. And Yarn clusters consist of a single resource manager and then a node manager for each node. And what running Spark in Yarn does is sort of map these processes onto your Spark worker and Spark master, or your Spark driver and your Spark executor, your processes. So in Yarn, applications run inside containers, which is separate from Docker containers. It's just sort of an abstraction here, with an application master in its own container that basically manages the other containers. And when you're running Spark in Yarn mode, the Spark driver is acting as the application master, or those two are sort of interchangeable. There's a Spark application master, which is running the Spark driver, which you can sort of see in the diagram here. And then node managers track resource usage and report back to the resource manager, which can determine how many resources are available. So in this case, where before you would submit an application and have the master and workers spawn, you would have the master tell the worker nodes to spawn JVMs for the driver process and the executor process. Here, what's going on is you submit it, the resource manager sees that, and it asks a node manager to start a container for the Spark for the application master. And then the node manager takes that request and actually launches that container. The resource manager allocates resources for the application, and is then the application master requests the node managers to create executor containers. The executor containers start, well, the node managers start the executor containers based on that request, and then the Spark driver, which is running inside the application manager, communicates with the executors, which are running inside their own containers. So ultimately, it's sort of a similar setup where there is a driver node that communicates with executive processes because that's sort of integral to Spark, but where those things live is slightly different. They're in containers that are managed by Yarn Resource Manager and Yarn Node Manager now. And then the Yarn resource allocation details. So where Spark Standalone only had the first in, first out method of scheduling, where resources basically get reserved by the first process that gets to them. You can run Yarn in that mode as well, but also you can run it in capacity mode, where it will guarantee a certain amount of cluster capacity is available, depending on your settings. So if you have 2 or 3 organizations, you can each guarantee a share of the cluster is available for them to use. And then fair will basically redistribute as applications are added so that all applications have a roughly equal share of the resources on the cluster. Yarn defaults to 2 executors per node and 1 core per executor. Those numbers are generally going to be low and can be increased in the settings. And then Yarn, when it creates containers, container JVM processes, it needs extra memory overhead for those, for the container processes and the JVM heap and all those other components. And if the executor tries to get memory that is beyond the executor memory setting and the memory overhead setting, your containers will crash. So the memory allocation is a little bit more important in Yarn versus in Spark Standalone. But also this means that if you set these settings poorly for your particular application, you could end up with containers that have more memory than they need, where you could fit another executor on some of these individual nodes, but you're not, because you're using that memory for extra memory overhead or providing too much executor memory. So it's a way to sort of misallocate resources on your cluster. And then we didn't really talk about the Spark Standalone Spark Master UI, but basically it lists all your applications. If you've ever used DSE, it uses Spark Standalone. It has that normal Spark Master UI where it lists all your applications that are completed, which are running, et cetera, and the Yarn UI for this is a bit different. Generally, all the same information is there. You have access to the logs through it. But specifically, you're looking through the Yarn UI for Yarn applications, rather than looking at Spark Master, keeping track of specifically Spark applications. And then Yarn also offers dynamic allocation, where your applications will basically start with a specified number of executors. And then if there are tasks that are pending for a long time, then the cluster is able to assign more executors, or the application can request more from the resource manager and get granted them in order to put more resources toward that application. All right, we're about to move on to Mesos. So if there are any questions about the previous ones, now is the time. All right, so Mesos, I don't actually know where the name comes from. It's an Apache project. I believe I read somewhere that Siri was running on Mesos or had run on Mesos. And Mesos uses masters, workers, and frameworks similar to frameworks are similar to applications in Spark Standalone, but sort of a more expansive concept. So your masters schedule worker resources among the frameworks that want them. And workers launch executors which execute tasks. But the applications, the frameworks that Mesos can run are beyond Spark. It can run things other than Spark, like C++ code, Java, Python, etc. And it can also schedule applications that Spark cannot schedule. So Spark can schedule CPU and memory, but Mesos can also schedule access to disk space and network ports and even other custom resources that are user defined. And then Mesos, the way that the master works is it offers resources to frameworks rather than the frameworks demanding resources from the cluster in order to be created. So in your Mesos cluster, you have your client JVM, which is running your Spark driver, which is specifically using the Spark Mesos scheduler, which is different from the other schedulers in the way that we'll talk about in the next slide, as well as your Spark context. Other than that, it's basically a normal driver mode, old driver. And then that communicates with the Mesos master in order to determine which resources are available. Basically, the Mesos master, when it has free resources, it will offer them to one of the nodes that needs them, whether it's the executors or specific applications. Sorry, I lost my train of thought a little bit. So your application registers with the master. Let's just follow this chart for a second and I'll see if I can pick it back up. The master offers resources to the client JVM, and you accept the offer and start tasks. Okay, and then Mesos starts your task containers. The Spark communication is going on between your Spark driver and the Spark executor as is normal, but those things are sitting inside Mesos task containers that have access to resources based on that sort of offer from the master. Yes, so, okay, I don't know why I skipped one. The resource allocation for Mesos. So the scheduler is special. In coarse grained mode, the scheduler will run one Spark executor per Mesos worker. So you saw that sort of here. There's one Mesos worker to one Mesos executor. And then each one inside has a number of tasks lined up for the Spark executor to work on. In fine grained mode, you can run one Spark executor per Spark task. So if you see all these little T boxes inside the Spark executor, in fine grained mode, each of those would have its own Mesos task container with its own resources. So generally, things take longer to run in fine grained mode, but you are more able to sort of micromanage the resources on your cluster. Because more tasks will be starting and finishing, you could potentially lock up less resources in these individual Mesos workers at a time. And then Mesos tasks get executed in containers. So while previously we talked about Yarn having containers that will run JVM processes, in Mesos, these containers are actually running individual tasks, and it will either be in Linux C groups for the containers or actual Docker containers. So it's sort of a precursor to Kubernetes in that way. And Mesos, of course, has its own UI that shows which frameworks are running. So you can get the same information as you would look at the Spark Master UI for your Spark applications, but also whatever other potential frameworks you're running on the cluster will show up there. And then the scheduling is done by the resource allocation module on the Mesos master and the framework's internal scheduler. So the internal scheduler is the fine-grained or coarse-grained mode that determines what which Spark executors inside the Mesos workers are being created, and then the internal scheduler, and then the resource allocation module determines which containers exist and what they're doing. And then those resources are distributed using the dominant resource fairness algorithm. Basically, what it does is it determines a dominant resource for your cluster and then splits up all of your existing frameworks by the amount of that dominant resource they're using. And then whichever ones are using the least get offered more resources by the master. And if they accept those resources, then they get them. But if they reject those resources, then they're passed on to the next least resource using process. All right, and like I said, Mesos is depreciated. I believe it's reached end of life and will probably be being removed from Spark sometime soon. And then lastly, talking about Kubernetes, you use the Spark submit to submit a Spark application to a Kubernetes cluster, as long as it has access to a Docker file for building Docker images that will run Spark processes. Spark 2.3 ships with one, but also it contains build tools for creating your own. If you need, say, a custom Spark R Docker image for your Kubernetes cluster to be able to run a Spark R process or something like that. You can build those with the tools that are provided inside the compiled Spark binary. So the way that this works on a Kubernetes cluster is Kubernetes will create a pod containing a Spark driver, and then the driver creates executors that it needs to run tasks in its own pods. So it's directly it's using Kubernetes to manage that driver executor communication that is sort of the basis and shows up in all of these different resource managers. So we see here Spark communication going between the driver node and the executor node. We see here between the driver and executor nodes. We see here between the driver and executor nodes. Kubernetes is enabling the same sort of communication, but those resources are determined by Kubernetes. Everything is managed here by Kubernetes. So I can't really talk about the resource allocation, what the sort of defaults look like in terms of how many executors are created. No idea how any of that works. So maybe a potential talk for a future episode. Future launch. And then the resources used to come up with this talk: Spark in Action, which is an actual book that discusses local, it discusses Spark Standalone, it discusses Yarn, and it discusses Mesos. It doesn't really talk about Kubernetes because I don't think that the version of the book that I was reading was out when Kubernetes had become as popular as it is now, or supported Spark. And then there are documentation for each of the resource managers, other resource managers that we talked about. Local does have its own page, but it's sort of, it's not included. It's not in the same format as the rest of these because it's talking about just the way that you provide the master. It's a different documentation page. And then there are docs specifically for Spark Standalone that will tell you how to create a cluster and the quirks of that cluster, as well as for Spark Yarn and Spark Mesos. All right, I am just about ready to finish up. So if there are any final questions, now's the time for them. And if not, I will pass it back to Akwe.
All right. First of all, I'd like to thank Obi for powering through today. I know you're still recovering, so I'd like to big thank you for powering through and delivering a good lunch this afternoon. I'd like to thank everybody for tuning in. I invite you guys to like the video and subscribe to the channel if you haven't already. Also, please do download our free Apache Runbook while that current edition is still available. It's listed there in the chat or available on our website as well. And yeah, see you guys same time, same place next week, and have a wonderful week. Take care, everybody. See ya.